Let me enable the attendance first. You guys, attendance enabled. Yeah, good morning, everyone.
Sir,
Yeah, go ahead.
sir, I just now noticed that I did fill out the attendance form yesterday.
Okay. S- just a minute. I'll tell you what I'll do is if by the time people join, I'll just mark a few attendances. Uh, 21.
Sir, I have also missed one attendance that I have not filled the form. Cause of.
Uh, for yesterday, right?
No, sir. The previous class, matlab, uh,
You have
yesterday
to
एक
tell me
class I have.
the date directly. Okay. Let me
Okay,
first start with
okay,
CSAI
sir.
2112. Okay. Let me just mm, CSAI plus, huh? Yeah. And just a minute. Yeah. Tell me your roll number, Mohit. Uh, Mohit. It was Mohit, right? Who said I missed the attendance?
No, sir, it was me.
Okay. Okay. Tell me your
Sir, I'm typing it.
what is your roll number?
Sir, I typed it.
Just a minute. Okay, I was not looking at chat. 2000, uh, 20037, right? Okay.
Sir,
CS.
013, sir.
Okay, that is why,
Sir, 20200013. That's
it's
CS.
CS, right? CS
Yes, sir.
0.
Excuse me, sir.
Yeah, go ahead.
Sir, actually, even I was unable to mark yesterday's attendance.
Uh, guys, then just drop me emails. Some of you guys sent me an email yesterday night. I could not do that. Those people I will anyhow mark. Otherwise, just send me with the date. What date did you forget, and I will mark it. Okay.
Thank you, sir.
This one, the one that I already started. Sorry. LCS 2020. What is it?
013, 013, sir.
013. Okay, fine. Okay, the rest I will just drop me emails. I will add it. Okay, and then just tell me what date it is. Which date did you miss, and then I'll add it. Okay. Okay. How many people do we have? Yeah, Nitin, just send me an email. Okay. We had some volunteers for today, right? Are they already here? Volunteers for. I think we had far too many volunteers for today. Actually, already. Shepherds. I don't have to pick anyone. Uh, I will pick one, but others, shepherds. Who would like to be a shepherd? No volunteers? This is it? Was
So
it
if
in the
no one
other
else
batch?
volunteers,
Oh, uh, okay. So maybe it was in the other batch.
Yesterday,
IT. Yeah, go ahead.
I was suffered yesterday.
Oh,
Today,
yeah, yeah, yeah. Right, right. So we have the same shepherds from yesterday. So please, is everyone there from yesterday?
Yes.
Just type your names on the chat. Sahil, I can do that. Actually, what I'll do now is I will basically what I'll do is I'll just share that I have a folder on Google Drive. So what I'll do is I'll share that folder with the batch. But that is that seems to be the best way to do it. You guys can keep checking your attendances, because otherwise sending it one by one is very difficult. Or what I'll do is at the end of the month, I will just add all the attendances to one sheet and then I will share it with you guys. Okay, so then you can simply, I usually don't care much about attendance. This is a kind of academic requirement that I have to somehow give up. I've basically given up, right? I mean, there are certain things in which I have no rights. I have no controls, so I have simply have to give up what what the administration wants me to do. So attendance is one of them. So if you remember you forgot, just drop me an email and I will add it. Okay, so please, the shepherds. Here we have the shepherds: Nischal, Vivek, Karthik, Khyati, um, uh, Sahil. No, don't worry. It was about attendance. Don't worry. So Nischal, Vivek, Karthik, Khyati. Was there one more or like four only? Four only? Shall I pick one more? I want at least five. Uh, okay, let me pick one. Actually, we should pick at least one person randomly. That way, even though the probability might be very low, but it is not zero that you might be selected. Uh, mm, see, okay. Mm, Let me just pick up one person. So, Avantika Modi, is she here?
Yes, sir, I'm here. Sorry for the background noise. I'll bring my earphones.
So, but can you be the shepherd, one of the shepherds?
Okay, sir, I'll try.
But we'll want this background noise to go away.
Yes, sir, I'll bring my earphones right now.
Okay, so Avantika is fixed as the fifth shepherd. So now we have five shepherds. Avantika will bring her headphones and then she'll join. But for the others, we should start straight away. We have wasted already a lot of time. So let me open up that document. Mhm. Okay, so shepherds, till where did we cover yesterday?
so we have to start from third question.
Okay, so start. So the third question is, what is a procedure and how it is different from algorithms? So let's start.
May I start?
Yeah, go ahead. Anyone can start.
A procedure is a collection of instructions which perform a specific task. The sequence of the procedure has to be followed step by step from first to last or not to be followed at all. The main difference between procedure and algorithm is the format. Procedure has to be in format which is not specifically defined for algorithms. Someone else continue.
What
So
is
if you're
procedure? Procedure. The
Second part of the question, guys.
so if you're given a problem and if you list out the solution to the problem step by step in a stepwise manner, and you follow throughout the steps from the beginning to the end without skipping out anything or leaving it in between, then it's listed as a procedure. And how it's different from algorithm is you don't necessarily have to follow throughout the whole thing in algorithm. In algorithm, you basically just list out the solution to the problem in a vague manner, and that's just it.
sometimes we have to use a single formula many times in our command. So in that way, it is very hard to use that formula and procedure every time. That's why we define this procedure, and in that procedure initially we solve that particular formula and then we simply use that formula as its name. So it is the importance of procedure. It's more like in mathematics we use Pythagoras theorem. We don't have to always derive that Pythagoras theorem. We can only use it by its name. So that is what procedure is like. And algorithm, yeah, we algorithm is just that we define all the steps and we do the things whole in a whole.
Hello, am I audible?
Yeah, you are.
Okay, so an algorithm is a description of a method for accomplishing some task, and a procedure is the actual recipe or the method for accomplishing a result, such as solving a problem or performing a task. So, a procedure is usually it consists of finite steps, sequence of discrete steps, and then each step is an operation or instruction that can be performed by the agent, and each operation or instruction is finite. It's represented finitely, and the device can carry out the procedure automatically. Algorithm is the description of the method. It's like, for example, for driving to a friend's house, it can be like find your keys, then get into the car, then start the engine, then put transmission into gear. So that is like an algorithm. A method is what we are actually doing, finding out our keys, getting into the car, starting the engine. So that is the difference basically. Thank you.
Yeah, so she used the term method. Basically, as of now, we are just using the term procedure. But yeah, I mean, method is another word that is in the object-oriented realm, right? So, but for now, just assume that method and procedure are just the same.
So, any doubts?
Sir, can we say that algorithms can be stopped and procedure doesn't halt or stops?
Sorry, can you please repeat your doubt? What is it?
Yeah. When we write the instructions, it can be stopped at somewhere else, but the procedure cannot be stopped or it continue to write.
No, see, that's not the concept. A procedure is a collection of instructions that to be followed to do a specific task. An algorithm, like both are complete within itself. An algorithm is a sequence of steps that we use to approach a problem. Both are complete within itself. We can't leave anything incomplete. Does that answer your question?
Okay.
Yeah.
Guys, sorry, I think one of the issues that I have done, this is my mistake, is that I have probably overly complicated the concept of procedure for you. So here's a very simple way to understand what a procedure is. When you write an algorithm, um, as I said, right, algorithms can be very vague. and very precise, right? So um, there is really no guidelines on how to write algorithms. So many a times what would happen is when you write algorithm for something, essentially you are writing, you write a lot of things that are too abstract, right? For example, if we take up that rocket thing, right? What if we want to launch a rocket? Um, Someone can probably write an algorithm for launching a rocket on a piece of paper, right? Simply say, fill up, if it is a four-stage rocket, build first stage, build second stage, build third stage, build fourth stage, put fuel, put on, launch pad and launch. So this is also an algorithm, right? But you understand that this algorithm is not really, for someone who wants to build a rocket, this is probably too vague, right? So in one, you can also go one level down. So in the second level, you can basically start explaining what exactly does it mean by saying build the first stage, okay? So then building the first stage itself could actually be another algorithm where you say, okay, in order to build the first stage, these are the things you should do. So the whole concept of procedure is that at some point of time, at some level, your instructions are detailed enough to be simply converted into code, right? So at that point we basically create a procedure, and then we compose a solution with the help of procedures, right? So the simple example that I gave in the slides was, you can probably calculate discriminant in a different procedure, and some of you sent me the homework, right? Some of you actually did the homework. I'm very happy, by the way. And you sent it to me over email saying that, sir, this is right or not. And you can see that in order to solve those linear equation in three variables, you have to find you have to prepare a matrix, and then you have to find that determinant, right? And this part, right, or what do you require to find a determinant? You just need to supply a matrix. It doesn't matter how that matrix was calculated, from where the matrix is coming, okay? So this is, calculation of determinant is a task on its own. It is used as a subtask when you are solving a linear equation, but it itself is a task that is basically coherent, okay? The term is coherent as in you can actually give it a proper name, that this part of my algorithm is about computing determinants. So this is the whole idea, that procedure basically is a kind of an operation which you can actually explain in parallelly to the overall procedure, right? So essentially you can call it, you can give it a name, you can say that procedure in many cases can also be used in some other algorithm, okay? It's not necessarily true that you use it in just this algorithm. So this is the overall idea. There is really no proper definition of procedure. The idea is that you collect certain statements which which are related to each other, which basically are trying to solve one simple problem at one place, and then you basically call it as a procedure. So now, from here onwards, you don't have to explain that stuff all over again. You simply say there is a procedure to calculate determinants, and I simply pass these parameters to that procedure. That procedure will calculate determinant value and send it back to me. So this is the overall idea of a procedure. A procedure is simply a collection of statements, and these statements perform some specific task. Okay. Now I can look at some of the chats. Otherwise, you can continue. I'll have a look at the chats.
Okay, so going on to the next question. This is a quadratic equation solver algorithm. The box denotes that it is an algorithm. That means there are a series of steps that helps us to solve a quadratic equation. So what are the inputs here? We input the three variables, that is A, B, and C, that helps us in completing the equation, and the algorithm solves the equation and gives us an output, that if discriminant is greater than equal to 0, then it will give us the two roots of the equation, that is x1 and x2, And if discriminant is less than 0, then it will inform us that there are no real roots. These basically are the outputs. And same, by the box quadratic equation solver algorithm, we mean that it is a system that is a series of steps that basically helps us in solving a quadratic equation.
Okay, so the inputs here are A, B, C. They
Yeah,
are
ABC.
yeah. So ax square plus bx plus c, the coefficients of x square, x and constant term in this equation. Sorry, ax square plus bx plus c equal to 0. They are the inputs here. The outputs may be roots or no roots. When the discriminant, that is b square minus 4ac, is greater than 0, then there are two different roots. When it's equal to 0, then there are two equal roots. And when it's less than 0, there are no real roots. We are not talking about complex numbers here. Okay, continue. You guys.
Yeah,
Any doubt?
same here. Any doubts?
Hello.
Yeah.
Yeah, no.
I think it should contain one more box before that, checking that if A is not equal to 0, because if A is equal to 0, then it should print that no quadratic exists.
Yeah, obviously we are thinking about that constraints before giving it.
Yeah.
I think that as it said, where it is a quadratic equation, it is compulsory that a not equal to 0.
Yeah,
You
yeah.
need to mention again.
No, because if in a program when we declare A, then it will be in the variable, means it will be int double, or then 0 is included in that format. So we have to create one more condition for that.
Yeah, obviously we can
So then that condition
make
will come
one
into that
condition
box
that it
now.
is not a quadratic equation.
That condition will come into the box of that algorithm.
Like if a equal to 0, the equation is not quadratic.
Uh, yeah. So let me intervene here. So this is a very nice point that we should also have a check for A. So this is where you can probably see that how is the world of algorithms different from the world of programming, right? When you enter the world of programming, you will have to do what we can call as some kind of exception handling. Exception handling means, what if my user is an idiot? Okay, and by the way, there is a very uh, very good saying that I read somewhere. So the universe is currently a place where people are trying to build bigger and better idiot proof systems, and universe is trying to build bigger and better idiots, and so far the universe is winning. Okay, so you have to write code in such a way that even an idiot can use your program, and it is a daunting task. Okay, even a simple addition or subtraction or multiplication program, there are so many ways in which it can fail. Okay, so we writing a program itself is a very writing a program is not difficult. Writing a program that can cater to a number of idiots is a very difficult task. So whomsoever talked about a equal to 0, it is actually a very very good point that in reality, when you start writing code, you will have to think about these things, that what if yeah, kind of that. So what if the user enters this, what if the user enters this, what if my program is simply doing a division, but the user enters 0 as the divisor, what will I do? So all these cases that you guys have discussed, this is important because when you write algorithm, many a times you actually don't talk about these things. Okay, you don't really say that what will happen if something like this happens. You simply assume that all the inputs are properly given, but when you write a program, you do have to check all these things. But again, the idea is that who is it that you are building it for? Okay, what is the target audience? Is your target audience a person who simply don't understand what a quadratic equation is? So in that case, that person might actually try to give a value of 0 for a, or you are building this system for somebody who's a genuine user who wants to genuinely solve quadratic equations using your code, in which case the inputs that you will get are probably all good validated inputs. So as I said, it's a bit difficult. Where do you draw the line? Exactly what level of yeah, Gagan, that is the point. That the idea is, when you actually build a program, and you give if you give the steering to a monkey, right? You cannot reason with how he or she drives the car. That is the idea, that once you have created the program, and you are seeking inputs from the user, you simply do not have any control over the user. Okay, leave aside 0. If you ask for an input from the user on the command line, the user might type ONE, okay, 1, and not 1 the digit. Okay, then what will happen? So these are some of the issues that are not straightforward, to cater to. And if you actually get into the details of how to do this validation, you might actually be too overwhelmed in the beginning itself. So that is why when we are teaching a first course in programming, we basically say you are the user of your own program. Okay, I mean, so don't assume that a will be 0. Okay, a will be something that is not 0, something like this, right? So essentially, there are so many levels of validation that you will have to go through if you are building a real system. So now you can start appreciating the effort that people put in when they build real systems. Okay, um, this this uh, this is actually a very difficult task, to build systems that be used by be can be used by everyone. See, AIs and machine learning. Okay, there's a saying in Hindi, "दूर के ढोल सुहाने होते हैं," right? So AI and ML they all sound pleasing and interesting when you see them from a distance. The moment you actually go inside and start looking, there are so many ways in which AI and ML can fail as well, right? It's just that it can fail in some other ways, rather than the conventional ways. But they actually have far more risk if you put them into some production environment, as in when you put them into actual software that people are going to use. So that is why uh, that is why yeah, Vatsal, I mean, that is the point, that essentially building idiot proof systems is a very hard problem. Okay, and in fact, let me also say this out aloud, that when you do programming, there are usually two types of programming that you learn. Okay, one is the competitive programming that you guys are probably already doing with your seniors. Okay, so competitive programming is required for you to get a job. So whenever you will sit in placements, your companies will ask you questions that are basically associated with competitive programming. But once you actually land up inside an organization, from there onwards, your competitive programming skills are not really that useful. From there onwards, it's your system building skills that will be useful. Okay, so you don't have to write code um, which can execute really fast. Okay, that is, I mean, if you can, it's good, but they don't really care much. You have to write code that is easy to understand, that is easily maintainable, as in, let us say you leave the organization and go away. Someone else will have to come and have a look at your code and modify it if required, right? So if you've written a code that is too geeky, as in, that runs very fast but it is very difficult to understand, you'll be reprimanded in your company. Okay, they don't want, for them, right? They don't care if your algorithm runs in 100 milliseconds or 600 milliseconds. Okay, as long as it is in milliseconds, they don't care. Okay, if it is 100 or 600. So your algorithm, of course, it matters if the size of your audience is huge. So for example, your competitive coding skills will probably be useful in companies like Google, for example. Okay, they work at or Facebook. Okay, they work at scales of millions. Okay, there even even 100 to 600 or 100 to 200 thing, when you multiply it by million, it will become really a big term, right? So there it might actually be useful, but otherwise you'll have to learn the art of system building, coding for systems in such a way that so that is the thing, right? When you write competitive programming code, you are pretty sure that the input file you will get will not have an incorrect input, right? And if you can have that incorrect input, it is specified beforehand in your problem statement, so you can write uh, code to check for it. But in general, you will assume that the input file that you will receive will be properly formatted. It will have your inputs properly given. Everything will be proper. And so you simply concentrate on solving the problem. But when you write code for building systems, you put more effort in actually doing these things, these validations. Okay, because your user could be an idiot. Uh, so so this is the issue. This was I just wanted to talk about this because someone actually discussed the a equal to 0 thing. So this is very important, that you have to learn both the skills. Competitive programming skills can get you a job, but once you go in the job, there you need the skills of system building. So there you will be required to think from the perspective of a user, that uh, what can a user actually do. Okay, and I have to have safety nets in order to catch any unexpected behavior. So anyhow, so let's just move ahead. So this, I think, is clear. Are there any doubts in this part? This. So does everyone understand what this figure is and what this figure actually means? Any doubts? Please ask now. Okay, so I'm assuming things are clear now. So let's move on to the other lecture now. The other lecture was about variables and constants. So I'm going to probably write some questions here. Mm, Let me just open up that presentation. Where is it? Uh, yeah, let me just put up this slide. Okay, and this is a good discussion point. Screen. Just a minute, guys. I'm just putting a small screenshot from that presentation, and you guys have to discuss that. Capture, insert picture, profile. Where is that? Shots. Yeah. So you have to discuss what exactly is this picture. I'll just make it a little smaller. Okay, what are the red dots here? Yeah, this is the question. Okay, Shepherds, you can start.
Okay, so A, B, C, they are the coefficients of x square, x, and the constant term in the equation ax square plus bx plus c is equal to 0. Um, okay, here D. D is a variable in which we are storing the discriminant of ABC. Discriminant calculator is a procedure or a method or whatever we can say. They are already defined, and they are defined such that D it returns the the method returns the value b square minus 4ac. Okay, and after returning, it will store it in the variable d. So, in previously we explained that if d is equal to 0, then x1 is equal to x2 is equal to minus b by 2a, because they will have equal roots, and else if d greater than 0, then we will have two different roots. The formula is already given, and okay, wait. Yes, and then it will return x1 and x2 as two different roots. Okay, so I'm explaining first one or second one.
Sorry. I have added two pictures. You're doing fine. After this, you will explain the second one.
Okay. Else, no real roots because d is less than 0. That is the only condition left. And we are not talking about complex numbers. Anything I missed out?
So
Yeah.
you have to discuss those
In
red
my
circles more. This is the point that how are those
Yes.
two red circles, right? Okay.
in my science, we
Okay.
have
So
learned that A, B,
ABC.
C are coefficients, but now, but in this command, we know that a quadratic equation is in the form ax square plus bx plus c is equals to 0, and here all the terms except a, b, c are the, we can say that it acts as a constant because that particular is the permanent equation, and a, b, c here are the variables. So yeah, here a, b, c are the variables, and we can give the inputs, and because of that we can change our quadratic equation. Now the discriminant, as Avantika has said already, discriminant is initial procedure. We have already defined the discriminant and its value is defined as b square minus 4ac. So we can just use that particular procedure here, and after doing that, x1 and x2 we defined here as variables. So yeah, that's all for the first picture.
So guys, any doubts as to what are those red circles and why have I marked them? If you have any doubts, please ask. Otherwise, you can move to the
There is
second
no
picture.
doubt, then I will move to second. In the second part, all the circles you have marked is all act as constant. As we can see, they will not change anywhere or anytime. So that's
Yes,
why they are
with
constant.
with any quadratic equation, even if you change the quadratic equation, these red circles are not going to change. That is why they are termed as the constants. They remain constant even if we change the quadratic equations or move to any other quadratic equation.
So is this part clear, guys? Because uh, what I want you guys to understand is that if you are doing this programming for the first time in your life, this might be a bit confusing, right? That why is it that whatever we used to consider as constants are no longer constants, they've become variables. Okay, so this is a very important point in your learning. Okay, if you don't understand this part, probably you will not be able to understand programming at all. So if you have any doubts, just ask at this point of time.
So the procedure is looking like pseudocode.
Hello, sorry.
Yes.
Is looking same as pseudocode.
Yeah. It's like if d is equal to 0, it should be there, and somewhat, yeah, syntax. I'm not looking so much into the syntax. I'm just looking at the main logic behind the program. Okay, so library functions. Any doubts?
If there are doubts in the chats, if someone wants to unmute and ask, please.
Okay, so library functions. Library functions are the functions that is already predefined in the program. It's included under the header files. Like iostream.h contains all the input output operations, uh, and then math.h contain the math functions. If we want to calculate the square root of any number, we don't have to write the whole formula, and we can just put the sqrt function there, which is included under the math.h header file. Yeah, anyone wants to add more?
Can you go a little bit slowly, please?
So
I,
library
I'm sorry.
functions are
Yeah,
library functions are basically
someone.
predefined functions. It's like code that is already written and stored in in something called as a header file. These things are accessible at any point. Like they're already stored in the language. You can access them at any point. For example, if you want to find the square root of a number, you can access the math header file, and in that there's a function called square root, sqrt. So you can write math.sqrt, and inside the brackets you can write whatever number you have to find the square root of, and once you do that, it automatically executes and prints the square root of the number. I mean, it finds the square root of the number, and you don't have to write the code for that. You can access it using these library functions.
Yeah, it is like someone else has written a code. Someone else has done this job, and she has set a framework for us. So we can just use that framework for us. We need not write it again. We can just follow it.
There are the procedures already written.
Guys, there are some questions in the chat. We miss it.
We are saying na ki unmute yourself and talk to us.
Yeah,
Someone is
someone.
answering them.
Okay, so someone wants
Okay,
to
okay.
try explaining library functions, I think. Yash. And before that, sir, I'm trying to say that using this procedure of quadratic equation, can we make an algorithm? Uh, okay. Discriminant calculator is the procedure here in the quadratic equation solver. So there is already one procedure present for making the algorithm. Yeah, that's it.
Yeah, if Yash, you want to
Wants to
explain,
explain library function, yeah, you can do that.
yeah, you can unmute.
Why discriminating calculator is not an algorithm?
Because it is
It
actually
is an
doing this work.
algorithm, but we have already defined it so that it will be for our convenience, and we don't have to define it again and again. So it's like that. It's more like a formula that we have derived initially, and we just use that formula again and again so that it will be less hectic.
So let me intervene. Yeah. So basically, it is possible for you to say that I have another algorithm for calculating discriminant. It is perfectly fine. Okay. This is why I said that when you write algorithms, there is too much of vagueness. So I gave that example, right? If you what is the algorithm to build a rocket? You can always say build first stage, build second stage, build third stage, build fourth stage. Now, building first stage can be an algorithm on its own as well. Okay, so it's about at what level of detail are you going. So in this case, we didn't actually give a different algorithm just for calculation of discriminant, but if you say there is an algorithm for calculating discriminant, it is not wrong. You can always say it's about the level of detail. Okay, what level of detail would you like to go? So usually we go up to a level from where it is easy to simply convert it into code, right? So this is the whole idea. You can also then if even for calculating discriminant, you can write another simple algorithm which basically explains how multiplication is done, or how subtraction is done. So it's all about the level at which you would like to go, and usually this level is decided with keeping in mind the target audience. So who is it that your algorithm is intended to go to? So maybe a person who's working in the space field, in the space engineering field. Maybe the statement build first stage is enough. Okay, that person actually understands how to build first stage. So then I don't actually have to go at that level and tell him what exactly is the first stage. But maybe for a common engineer it would be difficult. Yeah, actually, it is a function only. It's just that function and method, these are the terms that we use when we talk about code, right? A procedure is a more generic term. Usually, you will have like a one-to-one relationship between, say, a procedure and a function. So the idea of writing procedure is that when you start writing code, you actually know that I have to create a function for it. But I have not talked about what a function is, so don't worry about it. Basically, as of now, this is similar to a mathematical function. Okay, so what do you do with a mathematical function? You basically say f of x comma y, or f of x, or f of x comma y comma z. So a function is basically a kind of polynomial, and in that polynomial, you if you give me the values for x, y, and z, I can calculate the value of that polynomial, and I can tell you one specific value, right? This is what we do in in mathematics, that if you have a mathematical function, and if it is an n variable mathematical function, if you give me n values for all the variables, I can plot that function in an n dimensional space. This is what you guys would have read in mathematics, right? So if it is a two if it is a Cartesian system with only two variables x and y, if I give you two values x and y, you can plot a point, right? This is in in somewhere in that direction, that if I give, for every function, if I give you the input variables and a polynomial, the polynomial might look like x square minus 2xy plus plus xz. Okay, so now if I give you the value of x, y, and z, you can actually evaluate this polynomial and give me one particular value. So the same thing is what a procedure is doing. So essentially, you are giving it certain inputs. There is some processing that happens. Okay, this processing, in the simplest case, let us say of the case of a discriminant, this processing is just calculating a formula. That formula is b square minus 4ac. But it need not be so simple. It can have basically anything, right? You can do anything with the input variables, as long as you have an output. Okay, you have something that you are going to send back to your caller. Okay, so in this case, the procedure quadratic equation solver is essentially calling, as in, it's the same as it sounds. Okay, calling means, I need some processing to be done, and I actually don't care how the processing gets done. The only thing I care is, I have a final result. So in such cases, when we'll do programming, you'll see that there will be certain statements where you actually don't write the details. You simply make a call, as in you simply invoke another procedure, another function, as someone has already pointed out. And you don't care how that function works. You don't need to know the code of that function. That function simply takes inputs, performs its tasks, and returns you an output. So this is the whole concept of a procedure. Okay, and as some people have already has said, you can always keep on going down. You can say a procedure for calculating discriminant uses a procedure for multiplication. So it's like this, right? I mean, it's up to you. You can go up to any level. You can have bigger function. Yeah, so procedures are hierarchical, Sahil. Hierarchical in the sense that you usually, when you start writing code, you will write like one main procedure. Okay, this is a nice point to actually use the word main. So there is actually one main procedure in your program, and that main procedure can actually call other procedures. those other procedures can also call some other procedures. Okay, so there can be a chain. So your main procedure calls a procedure X. Now whatever processing X has to do, it might call another procedure called Y. So what is it called? I've forgotten the mathematical term. So how do you write this G O f of X, right? G of f of X. What is it called in mathematics? Composition.
Composite
I've
function.
composite functions, right? So that is the same thing. Basically, sometimes you can simply say f is basically g of h of x, right? Does it make sense from mathematics world? um, some so if I'm
Not
not
use
wrong,
it for bathroom. Not for bathroom.
um, so someone's mic is on.
Sorry, sir.
Yeah. So in mathematics, we used to have this, right? I mean, you can basically say that f is basically g of h of x, right? So the same thing is there. Um, f could f could be x square plus 2y, or f could be g of h of x, right? I mean, so it's about how much, what you can always compose a procedure that is consisting of other procedures, which is basically calling other procedures to get its own processing done. The exact level up to which you go, that depends from case to case. Okay. So as I said, if you are probably building a rocket, then there will be this chain will probably be uh, you know dozens of there will be dozens of functions. So this composition, okay, this will be like f of g of a of b of c of x, something like this. The same function that you are trying to create, the same procedure that you're trying to create, it hierarchically calls up many other procedures. Or otherwise, for simple programs like quadratic equation, you probably only have one level of chaining. So don't get too confused with this whole idea. Actually, the moment you start coding, and when we reach yeah, we won't discuss call by reference, call by value as of now. It's probably too advanced to talk about those things as of now. But yeah, the idea is that a procedure is simply a unit of computation. Let us call it a unit of computation. Okay. So you compute something in a procedure. Now that procedure might actually invoke other procedures, okay, in order to get its own job done, or it might actually do its complete job all by itself. It depends. Okay, it depends on how you are trying to implement it. And library functions are basically some procedures that are already given to you by your language. Okay. And you can simply use them. You don't need to care about their actual code. It is given to you. You can simply use them whenever you want. And the classic use for library functions is for taking inputs and showing outputs. So usually we don't understand how complicated it is to you guys understand, right? So there are system calls that are supposed to be made in order to take even a single character of input from your keyboard. Okay. And there are system calls that are supposed to be made in order to send at one character of output to your screen. But it all works so seamlessly because there are different layers. Okay. And in programming, uh, you are given usually by all languages, you are given at least two library functions. One function to take inputs from keyboard, so you don't really have to worry how those system calls are being made. You simply use that function, you simply use that procedure to take inputs. And similarly, you have at least one more procedure with the help of which you can show output, right? This is like the bare minimum you require to make a program usable. So almost all languages, I mean, I don't know if there is any language that doesn't have library functions for input and output. Almost everything you can code on your own, but this becomes a bit more complicated. You can, by the way, code these things on your own. So we will study something known as pointers later in the course. And with the help of pointers, you can do so many things. Then uh, I'm not sure I'm going to teach that in class, but basically there is a function called printf, which is used to output messages. You would not even require using printf if you understand how pointers work. Okay, you can simply go and but that is what you should not try to do that. The printf method is given to you for this exact purpose. Uh, then this quadratic installer would be a procedure then. Yes, Radivya. This is what you'll do. Okay. Yeah, cout is basically the equivalent of printf in C++. Okay, printf is cout's brother, and see, Python is a much higher level language. Okay, um, and that is why many things that seem funny to Python developers, um, it's just right. They are born in a different era. Okay, talk to people who have used computers with the help of punching cards. Okay, so there used to be actual cards on which you will have to punch your inputs and give it to the computer. So this was way back when we did not have electronic computers. So there was something known as vacuum tubes. Okay, this is like far too much. Um, but the idea is that in any language that you are going to use, there will be library functions. Python actually has far too many library functions, to be honest. um, but in C you will get a basic set of library functions, and these functions are going to be used for doing certain tasks. Okay, so for example, I'm not going to explain to you how the system calls are made in order to take inputs, or how system calls are made in order to send an output to your screen. Okay, we will simply use the function and we'll get to know. So by the way, I am preparing the lecture for tomorrow. I understand that you might not get time, so what I will do is I will prepare two short lectures. It will be around 10 minutes of time. So just try to watch at least one lecture uh, before tomorrow's lecture. So maybe if the lecture starts at 10, get about 10 minutes of time in the morning, and watch at least one of the parts. And grep command, uh, so is I'll did I have a chat, did I have a session of bash with you guys or the other batch yesterday, where I was showing some commands? It was with you guys, or okay, with you. So Pranav, you'll have to tell me that. Let me
Yes, sir.
uh, just a minute. Let me share my screen first. Uh, mm, Screen. Mm, just a minute. I'll figure out. Is this the one?
Yeah.
Yeah. So yeah, this is like, I just wanted to show you some cool stuff. I was able to search this command straight away, right? So yeah. Anyhow, so this is the command. Password.
Triple ITL.
Okay. Okay. So what command did you say? Grep. Okay. I'll have to go to some directory, right, that I made yesterday.
It's a
Uh,
CD test.
Test. Yeah. Yeah. Thank you. Okay. Yeah. This was the directory that we made. I was actually showing you find command yesterday. So let me just show you something more. What should I do? Let me just create a command, a file. Let me add what okay, cat temp.txt. Uh, what should I add? This is a simple file. Okay. Uh, I'll actually add one more. Mm. Yeah, man works, by the way, Nikhil. You can actually try it. I tried it yesterday. Man is will show you a good page. Uh, Sorry. Okay. This is another simple. So now, yeah, it is a book. Okay, so the first thing that you need to know is just like find the most common uh, form of grep will be something like this. You say grep minus. Now it depends on you whether you want to use the R, R switch or not. R would basically mean recursive. So I do not have a directory. I do not have subdirectories currently. But if I had subdirectories, right? So within the test directory, I had like A directory. Within the A directory, I had B directory, and I want this search to be done, recursively, as in not only search just this particular directory, but basically all the directories that are inside that. Then we use this R switch, okay, R. And similarly, I is the same, ignore case. So on bash, everything is case sensitive by default. So if I want to search,
Sir,
yeah, go ahead.
sir, can we write RI or IR? It is same in both the
It
cases.
is the same. It is the same. It is the same. The
Okay,
switches
sir.
can go in any order. That is not a problem. The only exception are certain switches. So in some files, in some, let me just see if it has zip. It doesn't have zip here. Otherwise, for zip, there are certain commands for which does it have tar. Has tar. So let me just show you tar. So tar is an equivalent of zip. Okay. So basically what I do is something like this: tar minus cvf um, dot tar and star. Okay. Now here I can actually interchange C and V, but I cannot take away F. So basically minus F stands for the name of the tar file. So then wherever you put F, the immediate thing after that should be the name of the file. Okay. Um, but most of the switches in general are interchangeable. So I can, for example, say tar minus VCF. That will work. Okay, something else dot tar. Um, at this point of time, you should basically assume that the switches can be in any order. Okay. There are only specific cases where a switch has to be in a particular order, but in general, switches are not order sensitive. You can actually use any switch before and any switch after. Yeah, you can also write it like this minus. So basically, you can say something like tar minus C minus V minus F uh, C
Still,
dot.
what command is tar, sir? Matlab, what does it do? Tar is a command, na, sir?
Yeah, so tar is a command. It is similar to zip. Okay, it creates zipped files. Tar is another format for creating zipped files. Okay. So anyhow, let us go back to grep. Oh, by the way, you have a class. I should leave you guys, right? I mean, it's already 10. Do you guys have a class at 11? Okay, so I'll just take 5 minutes. So the way we use it is something like this. I use grep, then I use any switches. Usually the most common switches are minus R and minus I. And you should understand what they mean. They are basically for recursive and case insensitiveness. So it depends if you want to use these or not. But and by the way, I can, if I'm this and this and this, they are all equivalent. Okay. So if I'm using multiple switches, I can leave out the minus sign and just put it next to it. Okay. Otherwise I can also type it like this. So this is also fine. And then, so this is the first part. The first argument that grep expects is a string to search, a pattern to search. Okay. is grep like is like minus I for commands? Uh, I don't understand this particular questions, but let me just complete this. So the first thing that you do is you give it a pattern to search. So let us say I have that term file written somewhere, right? So this is the pattern to search file. The next thing is it wants to know what type of files should I look it into. Okay. Um, so I can basically say just look into txt files, just look into c files, just look into certain types of files, right? So here the last argument is what type of files would you like to do. You can also give it the name of a particular file. So I can basically say something like this. What is it? Temp, right? Temp.txt. uh, yeah. So you can see that it has said this is a line that I found in this particular file. Actually, if this file had multiple lines, it would have shown you something more. I'll just probably add some more lines to it. Uh, uh, okay, so mm, mm, so now let us give this command again, and I will remove the minus I part. Okay, but let us first look it with minus I. So I'm saying look for the word file in temp.txt, and any line where file is present, just show it to me. So this is what it showed. Okay, there are two lines. Now if I remove the minus I, then only one line is coming up. Why? Because now it is looking for exact file in small case. Okay, this particular file is not caught because I'm asking for case sensitive search. If I want this search to be case insensitive, I simply add minus I. Minus R is basically recursive. So let us say, okay, let me just show you minus R as well. um, mm, now let me show you this. uh, I'll have to then make it star. Um, so this is a tar file. I'll have to make it like this. So don't worry about the capital I. You don't need to know much about it. But let me just show it to you again. Um, so now you can see what it is saying. It is saying that temp.txt has this line. This is a complex file. Temp2.txt has this line. This is another simple file. And something slash temp dot. So something is basically a subdirectory. Okay. um, is there a way to see in which file yeah, this is what, right? I mean, in the first case Uttaran, I was just giving it a single file, so then it was not it did not show me the name of the file. But now because there are multiple files, it is also showing me the name of the file, that it found it in temp.txt, or it found it in something slash temp.txt. Okay. um, so if you have multiple files, it will show you the name of the file as well. So star essentially, as you know, right, star means everything. uh, yeah, so no file exists because maybe the uh, you have created this exactly the way that I have done, Nikhil. uh, okay. Debugging is not that simple. You have to actually look into multiple things. I'm just telling you the concepts. If it is not following the same concept, you can probably send me an email. And by the way, I have realized that the bash shell on Mac is slightly different from the actual bash shell. So if you're using Mac, please don't rely on that. We have seen it yesterday that it was not behaving properly. uh, so anyhow, so this is the overall idea. The way you use it is grep minus certain switches. Just don't look at minus I for now, okay? Just ignore minus capital I. By the way, minus capital I is different from minus small I, okay? So don't write capital I. It is a different switch altogether. So yeah, usually you will use grep minus r and minus I. You will give it a pattern. This pattern again can also have, other things. I'm not going into the details of patterns, but you can look into the man page. But basically this is a word that I want to search here. And then star basically means all the files, okay? All the files, all the subdirectories, everything. Okay, is it clear, guys? Or no?
Sir,
Yeah, go ahead.
sir, minus R stands for reverse and recursive both, or depends upon
No,
the
no,
command.
no, 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 not reverse. It is recursive.
And sir, yesterday you told it is LTR for reverse in
Oh,
Alice.
yeah. So this is something. So the meaning of each switch is different for each command. Okay, it's not
Okay.
a okay. It's not something that is universal. So the same switch will have a different meaning in different commands. That is why you will have to read the man page for that command.
Okay, sir.
That will actually. So if you do man grep, here you can actually see like this. This is basically what it. Okay, sorry. So this is what it is, right? Minus I stands for minus ignore case. Okay, and
Yes, sir.
similarly, uh, minus mm, this is what it should say. And minus R option would be somewhere up. It's actually a long man. Um, you'll have to you'll have to browse through this using your keyboard. It does give you certain things. The man page, something similar to VI. You can search, but this search is not that good, as good as the VI search. Even into the minus R option. Okay, I'm not sure. So basically, it was at the bottom left. Okay, sorry. Yeah. It's there. Minus R, recursive. So this is basically what it means. But and if you go to man ls, um, here minus R means reverse. Okay, so
Okay, sir.
different switches will have different meanings for different commands. They are not universal. Okay. Okay, guys. You
Excuse
have
me,
your
sir.
yeah. Go ahead.
So the asterisk sign is having different meaning in find and grep command.
No, asterisk is the same. Asterisk is a bash feature. Asterisk means everything.
So basically, sir, in find, so when we put asterisk, suppose we put it at the end. So we say that anything
Mhm.
starting with the given, whatever we have given, and
Yes.
ending.
So it is like this. Yeah. So basically, asterisk has the same meaning. It's just that its context changes. Context as in. So if I put it here, um, let me put it here. Asterisk. Uh, so
So it's
where
treating
is
it
it?
as regex, so asterisk in the name won't work.
Yeah. So regex, I'll have to go and check there. So basically, there are different types of regexes. So there is a Perl type regex. There is a what is the other type? So I have forgotten which regex type does grep use. I'll have to go and check. Okay, I'll have to go and read the man page. But yes, you can provide a wildcard character in the file. Instead of L, I can put some other wildcard character. So then what it would mean is that Fi any character at that point and E. Yeah. So sorry, I think asterisk is not the one that grep uses. I'll have to check. Regex. Mm, EREs. That is actually something that I'll have to read again. It's been long since I used any regex, because usually you don't need regexes with grep. You need regexes with find, but in grep you basically are already, so file already means asterisk file asterisk in some way. Okay, you don't actually have to uh, put it explicitly. But if I want to search something which has fi, then any character and e, then I'll have to actually check and see what is the regex pattern. So Divya, coming to your point, asterisk basically means all the files. This is the general thing that you will see in uh, that is a difficult question to answer, Shore. Um, yeah, regular expressions is equal to regex. Okay, I'm not teaching you regular expressions. That is, um, I mean, that is probably a bit too advanced anyhow. Uh, so yeah, so I'll get back to you for what is the right command for this. What is the right regex for this. But coming to the question that Divya asked, so asterisk essentially means anything. This is the overall idea. Anything can be replaced on with asterisk. This is a general thing for bash. Many I'm not sure if there are any particular exceptions where asterisk would mean something else. But this is basically a bash feature. Okay, asterisk essentially means all the files in that particular directory, something like that. Or it would mean, so it could be right that find has this, they have mm, they have made asterisk as a part of their expression language. Okay, that is possible. But in general, if you just write asterisk like this, so like I'll just say ls asterisk, it simply says, everything that is there in this directory, simply show it. Okay, this is what asterisk here means. So asterisk is a bash feature. Okay, it is a bash wildcard. In certain commands it will be used as it is. So and in this case, this is what is happening, that basically I want to tell grep to look through all the files, so I simply used asterisk. I can also say something like ls asterisk dot txt, so only the txt files are shown and the others are not shown. So asterisk is actually a bash feature. So which zip files? Yeah, grep searches within files and find searches for files. This is right. uh, Guys, let's just break now. I think you already have a class at 11, and
Sir, I have a sir.
yeah, go
Sir,
ahead.
sir, how can we go back to our main host?
Main host. uh, I mean, I have done an ssh and you want to go back, is it?
Yes, sir. Yes, sir.
Just control d.
Control D.
Yeah.
Okay,
Or
sir.
you could have also done, you can also do this exit. So let me type there. You can type exit.
Okay, sir.
Control D or exit, whatever is fine with you.
Sir, I wanted to ask that. So you said yesterday that minus I does like if you write minus I, it will mean insensitive in name. So
Yes.
does grep mean that insensitive in the commands like minus I or minus
Yeah,
I
yeah, yeah. So
minus R?
minus I in grep means insensitive in the text that it will search for it, right? So, I mean, so like I
Okay.
said, minus I file here, right? So then basically
Yes.
it will search for file, the word file in any case.
Yes, sir.
Yeah.
So sir, I was asking that does grep does the same to mine like writing commands in minus I minus R or writing minus IR or writing minus
Yeah, it is. Yeah,
RI?
it is the same. It is the same as I said, right? So minus IR, minus RI, minus R, minus I, minus R, they are all equivalent.
It will work without grep?
No. Grep is the actual command, and minus I and R, they are switches for that command. Switches are basically settings. Okay, so you are trying to use grep in a particular fashion. Switches are basically additional settings. You can always just write grep and something here, right, and that will work. But switches are optional switches, and you can give more specific inputs for grep to run with the help of these minus R and minus I things. There will always be a default. Okay, so by default it is
Okay.
case sensitive. If you want to make it case insensitive, you have to give -i. By default, it will search only within the same directory. If you want to use it to search recursively, you have to give -r. These are some of the things.
Okay, sir.
Okay, guys. So you are having your lab at 3. Today's lab will be a shorter lab, so it's only going to be a 1-hour lab. And then in the next 1 hour, your TAs will take your demos. And this is that. So I don't want to stress you too much. I don't want to stress you beyond 5 today. So today's lab will basically be a 1-hour lab, and so you will get 1 hour to do the assignment, and then the next 1 hour the TAs can take to take your demo, so that you are free by 5 p.m. This is the idea, right? uh, be prepared. You will receive the problem statement at 2:30, and your TAs will be online on 3, right? So for first half hour, just see the problem statement. If you want to read something, if you want to study something, if you want to prepare yourself, do that in half an hour, and then we will start the lab formally at 3 p.m. Okay, and you will get emails from your TAs, so that which room you are supposed to join, that you will get on your own email. Okay, so that your TAs will be sending to you. Okay, guys, thank you. We'll probably see each other at, or hear each other at. Oh, everything is allowed, Nehal. You are allowed to do whatever you want. Google is certainly allowed, uh, but everything is allowed, Nehal. And as I said, that you can use whatever resources are there at your disposal. This is going to be the same for every lab. Okay, you, that is what you'll understand that Google has its limitations too. um, Google has a lot of lot of knowledge, but you need to know how to dig out that knowledge, and that you will learn when you actually start doing these lab assignments. You will learn this art. Okay. Yeah,
So,
go
so
ahead.
what will be the mark distribution, or is there any marks for this?
So basically 10 marks for your submission, and 10 marks for your demo.
So submission that will be done today at 4 o'clock around.
Yeah.
Oh.
Okay. Avantika, talk to your friends. They know what is demo. Okay. So we'll probably meet at 3 p.m. guys. Okay. Bye.
Sir, are you there?